Hello, and welcome to Math for Moms and Dads. Today, we're going to talk about the idea of decomposing. My name is Eric Krantz, and I work for the Fresno County Superintendent of Schools. You can contact me via email at ekrantz@fcoe.org. So when we start talking about decomposing numbers, we start doing this in mathematics as early as transitional kindergarten and kindergarten here in California. And the idea of decomposing numbers is simply taking those numbers apart into smaller parts. So one example of decomposing the number 9 might be 5 and 4. So one way to make the number 9 is to add the numbers 5 and 4 together. Other examples would be 8 and 1, 7 and 2, 6 and 3. But there's many ways to make the number 9. And as our students learn that, it becomes a powerful tool for them in solving lots of different problems. Some curriculums and teachers will call this part whole. So you can see the whole is the number 9, and each part, 5 and 4, make up that whole. Even some teachers will call this making a mountain, which is just a fun, creative way of saying, hey, as we climb this mountain, what are the parts that get us to the top? Well, 5 and 4 make 9. But whatever way you choose to present this idea to students, the whole idea is that we're taking 9 and breaking it into smaller parts, or any whole number and breaking it into smaller parts. So we're decomposing that number. So you might ask, why is this useful? Like, what's the point? Well, for instance, we might have the numbers 6 plus 7. Now, moms and dads, I know probably if you loved math, you probably have that memorized. And if you don't like math, you know how to solve that problem. And one way to do it would just be to count. Like I might take the bigger number 7 and add 8, 9, 10, 11, 12, 13. However, one possible way that decomposing might make your life easier is when we're adding across 10, you can take that number 7 apart into 4 and 3. Because I chose those numbers because I know 6 and 4 make 10. And now the remaining 3, it's easy for me to add. 10 plus 3 is 13. That one's an easy one for me. So I like that decomposition. Another way that we might approach this problem is taking the numbers 6 plus 7 and maybe decomposing 7 so that I have doubles. We start talking about our doubles facts in kindergarten and first grade, and a lot of students love the doubles facts. So 6 plus 6 equals 12, plus the 1 more gives me 13. A second way that we might decompose the number 7 to make it easier adding 6 plus 7. This trend continues on as we move through kindergarten. But in second grade, students are supposed to be able to know from memory all the sums of two one-digit numbers. Now, they may do that and they may not. If we're not great at memorizing, that might be hard. And sometimes going across 10 is really hard for our kids. But if they know how to decompose, they'll still be able to solve that problem. As we move later in the year in kindergarten, we start to explore the numbers 11 through 19 and even into first grade. So if we decompose those teen numbers, we often can get a better understanding both of place value and of the number itself. So here we have the number 18, and we have a 10 frame that is full, representing 110. We also have a second 10 frame that isn't full, but there are 8 of the squares have circles in them, and so that represents the 8 ones. And 110 and 8 ones equals 18. So that's another way that decomposing numbers comes in to importance in terms of understanding our place value. And then that can move into later in third and fourth grade, we start talking about standard form and expanded form. And even though it's not on this slide, written form of a number would be like if we were writing a check. And some of us don't do that anymore because we do all of our banking digitally. But if you still write checks, you have to be able to write the number out in written form. Standard form is just writing the number, as you can see here, 452. Finally, we have expanded form. Well, if we've been decomposing numbers, then expanded form is not too difficult. The 4 in 452 represents 400. The 5 represents 50, and the 2 represents 2. And so we break that into expanded form and decompose the number into 400 plus 50 plus 2. This can come in really handy if you don't know the standard algorithm for addition or subtraction, because then you can add another number to it, and you can make the expanded form for both of those numbers, and then you're able to add that number together, whether you know the standard algorithm for addition and subtraction or not. So moms and dads, I know the temptation is, why can't our kids just learn the standard algorithm right away? It worked for me. But you know that much of the country, of the entire United States, and especially in the state of California, a lot of adults don't like mathematics. And one of the reasons is we don't have a true good understanding of it. So what this does is it creates a good conceptual understanding of what we're doing when we're adding and subtracting. So now we have 400 plus 300, that gives us 700. We have 50 plus 20 instead of just 5 plus 2, and that gives us 70. And then we have, in the ones place, 2 plus 2 equals 4. And when we sum those up, we get 774. Now, later on, our students will learn the standard algorithm. Towards the end of third grade and into fourth grade, they will use the standard algorithm for addition and subtraction on a regular basis, and they will know it before they leave elementary school. But when we're exploring the idea of addition and subtraction, these kind of ideas really give us a good conceptual understanding of what it is that we're doing when we're adding and subtracting numbers. So I hope that this little tiny look helped you understand why we might start to decompose numbers and how it plays a role in our mathematics system. Thank you so much for watching this. Again, if you want to contact me, my email address is below. Have a great day.